Hello everyone, my name is Drew Sukup. On behalf of VMUG, I'd like to welcome you to today's CloudBolt Webcast, Drive Dynamic Outcomes in vRealize Automation 8, presented by Sid Smith, Principal Solutions Architect at CloudBolt. Thank you for participating in today's webcast and for your continued support in the Global VMUG program. Before we begin, I have 3 quick housekeeping items to go over. First, today's webcast will be recorded and available for you on demand. You will receive an email with the on-demand link, so keep an eye out for that. Second, a Q&A session will follow today's presentation. All questions will need to be entered in the question window near the bottom of your GoToWebinar screen. Third, there will be a short online evaluation that pops up as you exit the webcast. Please take a minute and let us know what you thought of today's session and what you might like to see going forward. All live attendees who opt in at registration to share their information with the sponsor will be entered into a raffle to win a $200 Amazon gift card. The winner will be contacted directly by CloudBolt, so good luck. All right, Sid, I'll turn it over to you now.
Thanks, Drew. And as Drew mentioned, today's session is going to be 100% demo. So the only slide we're going to see is this agenda slide covering what we're going to go through. We're going to start out with an overview on the OneFuse platform to get some familiarity with what OneFuse is and what it does. And we're going to look at how you consume OneFuse with vRealize Automation 8, and then round that out on how we bring this all together to really drive those dynamic outcomes within VRA 8. I'm going to go ahead and stop sharing this slide and bring up the demo. All right, so OneFuse is a new product that we launched earlier this year from CloudBolt, but it's derived from the works of SovLabs. Right? So anybody who might be familiar with the SovLabs plugins for VRA 7, all of the modules and things that are in and coming in OneFuse are derivatives of that product line with one big difference. OneFuse is its own standalone appliance. It's no longer living and breathing inside of VRA and relying on VRA for its UI and all of the other things that surround it, the modules. So here we have the OneFuse UI, and currently in the 1.1 release, which is what we're looking at, we do have support for naming, Active Directory, IPAM, and DNS. The one big thing here is, historically, VRA just consumed the modules that lived within it. And now the modules live here within OneFuse. And so as we'll see when we go through, there is a plugin for VRA 8 as well as VRA 7 to consume the integrations that OneFuse provides. These integrations, if anybody has familiarity with the historical or heritage SovLabs modules, are very, very similar, making it easy to port from the previous versions of these modules over to the OneFuse versions. But we're not going to go into very deep detail on each one of the integrations. The idea is to give you enough content around these so that you can understand some of the concepts that we're going to talk about in just a little bit. So when we think about and talk about naming a little bit, well, one of the things you see here on my screen is this thing called a naming policy. Policies exist for all of the modules within OneFuse, and these policies are very important because that's what gets consumed from VRA. So when VRA says I want to use a specific, or I want to get a name for a build, it's going to get the name based on the policy that's been associated within VRA. And so we'll take a quick look at what a policy could look like. There's lots of different ways to do this. But in here, you'll notice we have something that most of you are probably familiar with, which is defining what that naming template or naming standard looks like, determine how we're going to go ahead and generate that name. One thing that's really, I really like about OneFuse is when we're doing things like this, we tend to want to understand, well, what is this going to result in? What is this going to create or generate? And inside of OneFuse, we can create these things called static property sets, where we can go ahead and associate one to be active in the interface and use that to simulate inputs that might be coming from a requesting platform like VRA 8. And while you're putting these things together, we can simply take a look and see that based on those inputs, what would the outcome look like? And within these templated fields, and you'll note here to the left, there's these little curly braces that tells us that we can use the Jinja 2 language here. We can use pretty much everything that's available in Jinja 2. So we can do logic, if statements, case statements. You'll notice we have these things noted as required, which a lot of our customers like to use, because if this input isn't fed in, we're not going to get the proper name generated. And so with this required bit here, if it's not fed in, we'll actually fail because we don't have all the necessary information. And then last thing I want to talk about when it comes to naming is this concept of what we call naming validators. And naming validators give us a way to validate that the name that we've generated with its unique sequence is going to be unique in your environment. And with OneFuse and our naming, we do support multiple types of naming validation. We support VRA 7, VRA 8, as well as DNS today that we will validate against to ensure that those names are unique. Couple other things here. Within each of the different modules, not only do we have the policies that will be consistent across the platform, but we also have, here we see managed names, and we refer to these as managed objects. So all of the modules will have objects representing anything that we're currently managing in your environment to give you insights and visibility into those integrations. So here we can see all these requests that come in from VRA 8. We can see the source that it came from, the requester, what was the actual generated name in this case, and what policy was used to generate that name. And so we can see we've got some different types of policies and things like that. We do support VRA 7 and 8. It's the same plugin that we actually use for both. It'll install a little bit differently with the installer for each one, but the installer detects the platform and sets them up appropriately for each of the different environments. And so you get this historical view of everything that's out there in your environment that's being managed by OneFuse or that's been provisioned by OneFuse itself. And then you can dig in a little bit deeper on the details to understand what was the API call that was made, what inputs were sent to us from the requesting platform, and what were the results that came out of that. So full visibility across that stack for all of those integration requests. Moving on, if we go and look at, well, we'll do Active Directory next. Here we see that again, we have those policies and we have those managed objects. Just the objects themselves are slightly different. Here it's, again, what policy was used, what's the computer account that we actually created, and we can get a little bit more details around where it was placed in Active Directory OU, so you have some insights and visibility into that. And then we can drill into that job again and get those more granular details as well. Looking at the Active Directory policy, we're going to see some things. Again, we'll see those double curly braces telling us that we can use template language to denote these fields. And just to go through some of the highlights, we do support build OUs. If they want to be used, they are optional, depending on whether they're in use or not. And then, of course, moving it to the final OU after the build is complete. We also support adding computer objects to Active Directory security groups within AD. And again, all of these fields are designed to be very flexible so that you can use that Jinja language in here to put in your specific business logic on how these things need to happen. Most organizations don't have an OU path or policy or placement strategy that's quite as simple as what we're showing here. So you do have that flexibility to make that what you need it to be. And then all those computer objects, again, are in here as managed objects. Once they get removed, those managed objects that represent those computer objects or any other objects from the other modules do get removed, but all of the logging information does get maintained so that you can go back and historically look at things that may have been created and removed and things like that. If we move on to IPAM next, again, very similar in here we have our IPAM policy. We have our managed IP address. I can see the IP that was associated from the IPAM. and I can see the host name that that's registered with as well in my IPAM provider. If you didn't take notice, I'll go back to the main screen. Currently in version 1.1, we do support BlueCat, InfoBlocks, and Men and Mice. We do have support coming for SolarWinds as well as Microsoft IPAM as well. So those three are supported for IPAM, but all three of those and Microsoft are supported for DNS in the current 1.1 version. So if we go in and look at an IPAM policy, you notice you can choose the endpoint type based on the supported ones that we have, and as long as you have an endpoint created for that, you can select that endpoint so that we know what to communicate with. And then you'll notice, again, like we've seen across the other modules, we have those double curly braces, giving you that flexibility to put in static or dynamic values that can be computed based on the request itself. You do have the ability to do custom NIC labels. An example might be if you have two NICs on a machine, the second NIC is going to be for a backup network. You might want to identify that in its label. You can also do host name overrides for these scenarios as well, whereas you might want the primary NIC to be registered in DNS or something and even in your IPAM to the primary name of the machine, but we might want to add something like -BK for the secondary one to represent that it's for the backup network or whatever it might be. And then as we move forward, you can define your subnets that this IPAM policy is going to represent. And it can be a single or multiple subnets that you define in here. So if you have multiple networks that can host similar or the same type of workloads, you can create one policy and put as many networks as you want within it. Within the network definitions, you also, again, will see these double curly braces, so we can dynamically drive values into here if we need to from the requesting system, as opposed to defining these values statically. And this becomes fairly important when we get to DNS and DNS suffixes and things of that nature, because oftentimes you might support different DNS servers even within the same different network for different types of workloads, or definitely support different DNS suffixes across different workloads that might sit on the same network. So these can be all driven in dynamically as well into the policies within OneFuse. And of course, you'll notice here we have multiple different IPAM policies. When we get into the VRA side of things, we'll take a look at how we can also, from within VRA, dynamically target which one of these policies are going to get used, as opposed to statically pinning it into a blueprint. And next, we're going to move on to DNS. DNS, very similar, again, in the sense that we have those managed objects, we have the policies. We can look at the details of each of the managed objects, so look at the records that were created and the details surrounding those records, whether it was just, in this case, a host record, or in this case, we're doing an alias and a PTR record for this particular deployment, and you can see which policies were used for that. So a very easy way to get visibility without having to go to all of those endpoints directly and see what actually took place. So if we go take a look at one of these policies, one of the nice things I like about this as well is you have flexibility in what types of records you want to create. Here I'm looking at BlueCat, so they don't really have host record types, but our InfoBlocks endpoint does support that, so you would see that on the InfoBlocks configuration or policy config. But you have that option of whether or not you want to create A records, PTR records, and then the choices of whether or not you want to validate on those. So typically at this point, we've already validated that the host name is unique, potentially even against DNS if you set up your DNS endpoints. But you do have the option to revalidate that before the record gets created. But then another option to do a post validation on that record so that you can know if that name is now resolvable in DNS. So if you have dependencies down the road in your deployment that need to resolve that host name, we can validate that it is resolving before we move forward. And you get some nice flexibility in, is there wait time you want to wait before we go and try and validate, and then setting the timeout on that for your specific environment, how long it takes to perform those things in your environment. So what we're going to do now is we're actually going to jump into VRA 8. We're going to look at how we consume these different modules within 8, and then we're going to come back over to OneFuse, and we're going to talk a bit more about these static property sets and look at some of the other interesting things that we can do with them. So first and foremost, we'll go look at, and of course, I've got different examples here, and we do support using vSphere blueprints, cloud blueprints, AWS, and some other things that I'm going to show you here within VRA. But we'll start out looking at a cloud blueprint. So in this particular blueprint, we'll start from top to bottom and work our way through. You'll notice I don't have networks on the canvas or any of those things. I'm doing that all dynamically using the OneFuse plugin. And then as we go through, I've got some inputs that I'm taking into this blueprint. And so right now I've got environment, location, app, and I'm also taking in size as well. And I'm not going to dig deep into what's going on with these inputs quite yet. I'll do that after we jump back into OneFuse. But I just wanted to point out that these inputs, including all the way down to compliance, are there, and we'll talk a bit more about how I'm going to use those to really extract what our consumer sees. And so real quick, if we jump over to right here, to give you an idea, I've got this simplified blueprint with some extracted information, right? I'm not asking the consumer to tell me specific CPU and memory or what network they want it on or those types of things. And not that you can't if that's the use cases for your environment, but in this webcast, we're going to look at how to drive these things dynamically using these extracted bits of information. And so if we go down and start looking at the resource within VRA, one of the things we'll start to notice is we have some VRA properties where we're setting the image and flavor, and we'll talk about some things we can do there as well in a little while. But then we have the OneFuse configuration down here at the bottom. And here we can see I've got my OneFuse naming policy where I'm going to tell VRA that I want to call OneFuse, and I'm going to tell it what endpoint I want to use. So you can use multiple OneFuse endpoints if there was a need. And we see this with organizations that want to do testing and development as well as production in a single VRA instance, whereas they could have different blueprints for those different purposes, and then have a development OneFuse instance and a production OneFuse instance so that they can build a blueprint, talk to the dev one, get it refined, and then migrate that over and start calling the production OneFuse instance. And then you'll notice I've got a templated value here, and this is where we start to see some of this dynamic nature, right? Where I'm not necessarily hard coding the policy that I want to call. I could hard code it in place of these double curly braces, but in this case, I've got another property defined here just so we can see the traceability, and I've given it a value, and that value is directly going to displace this using the templating available within OneFuse, and that's going to tell it what policy is. Now, within here, you can leverage the Jinja templating that's available in OneFuse, but you can also leverage all the native constructs available within VRA as well, like blueprint expressions. So either or, whichever you want to use there. And then for this particular deployment, I'm also calling an AD policy. And one thing you'll notice here, I'm also templating what AD policy I want to use, but you won't find it defined anywhere here in the blueprint. And we'll talk about shortly where that's actually coming from and how we're passing that through here and how that's going to be used to further dynamically drive the outcome of what we're doing here in VRA. I'm going to skip over the property toolkit one because we're going to talk about that after we get through the modules. But then we have the IPAM module and the DNS module here, and much like the ones we saw prior, these are templated as well. So I'm not statically setting any of these values in this blueprint, which is going to give me pardon me, a bit more flexibility and being able to drive these dynamically, right? As opposed to hard coding it and pinning this blueprint to being using specific policies and those types of things. As we come down further, we have some things referring to our property toolkit property groups, which we'll come back to. And so right there, basically the simple way of how we call those specific integrations that we want to call from OneFuse. Now, prior to building out your blueprint, there is a workflow package that you need to install. So we've moved away from using VRO plugins to releasing a simple workflow package that you would import into VRO. And we'll take a quick look at that. That you would import into VRO, and then it has a configuration workflow that you would simply run to install that package. So if we go, so once you import the workflow package, there's simply a configuration workflow that you'll run, and that configuration workflow is going to set everything up for you, including all of the EBS states in which all of the OneFuse modules will be executed and run. So the only thing you have to do is run that. Once that's run, as part of that, you'll also define your, your OneFuse endpoint. You'll give it a name. Once you've run that configuration workflow, you can then start associating these properties and the appropriate values to consume the integrations and modules that are available from OneFuse. Now, if we step back over to OneFuse itself, I want to dig a little bit deeper on these static property sets, because one of the things we talked about is creating static property sets that represent simulated inputs for validating any logic that you might put into OneFuse using that Jinja 2 language. However, these property sets have another purpose that they can be used for as well. And so you'll see we've got some of those that actually have in the description the OneFuse Property Toolkit property set. And what these allow us to do is consume these inside of VRA for whatever the purposes are that we're looking to do, right? If you guys remember, VRA 7 had property groups where you could associate property groups to a blueprint. If you're familiar with our property toolkit, in VRA 7, we enhance those property groups by allowing you to use our templating language within them and associating them within different areas of VRA that otherwise property groups weren't available to. Well, this is very similar in nature to that, with the exception that now these groups are located within OneFuse. So I could create property groups here that I can consume from both VRA 7 and VRA 8 and via API or whatever else you might be consuming OneFuse with. And they're a bit more flexible. So if we look at this particular example, folders, right? Say we're doing vSphere deployments and we want to dynamically determine the folder that those deployments are going to get placed into. And so here I've got a template for that. So my folder name is going to go into this path, and I'm going to then dynamically set the group and the environment, and it's going to get placed in there. However, when we start consuming OneFuse and even things like this from different platforms, they're done a little bit differently. So within VRA 7, we use this VMware.virtualcenter.folder property to set the vSphere folder. And so what we've done here is, you can see this is using nested JSON, which, totally unstructured. You can set it however you want. There are a few things we've done to make it a little bit easier for you, like if you use these OneFuse VRA 7 props or OneFuse VRA 8 props, those are reserved. So depending on the platform that's calling, it's going to look up the ones appropriate for the platform, whatever you've defined underneath there. And so here I'm determining what the group is. And you'll notice I'm referencing another property here. This property doesn't exist in this group. It's going to get pulled from another group based on some of the things we'll look at within VRA. We'll start to see where that comes from. Then ultimately, that value is going to get used for here. And then when this folder name is fully constructed, we're going to reference it down here. So I have that ability now to use all that template language here. And when I make this call from 7, it's going to automatically associate the right property and the right folder path to put it in the appropriate folder. Yet if I reference it from VRA 8, it's going to do the same thing, but it's going to use resource group name, which is what we would pass in the VRA8 to set that folder path. And then I can also define things for other environments as well. And all of this now is accessible within, so say VRA8, for example, I can access all these properties and their values using standard dotted notation. Right? And so this extends into other groups as well. If we look a little bit further, we have on our VRA blueprint, I have an input for environment. And one of the things we didn't look too closely at yet, but let's go back, is when somebody selects a specific input, it's setting a value, and you can see it's got this SPS underscore ENV, and then in this case it's dev. Depending on the selection, it might be test or prod, and those all correlate to these different groups that are within OneFuse. So if somebody chooses production, this particular group is now going to be associated with the request, and all of the name value pairs, or all these properties that I have within this property set, are going to be accessible inside of VRA, and including anything that I nest, I can also access via that nested notation. So if I go down, we can start to look at what this might look like, and there's some properties I have here for creating tags in VRA8, as well as creating tags in VRA7. So with OneFuse, we do support dynamically adding tags to your build as well, and using our Jinja template language. If you're doing it within these property sets, you can use that Jinja language in here as well. So as we start to go through, if we chose that production, all of those name value pairs and everything that's in there is going to get associated with this request. And then we have these other inputs as well. We've got location, app, as well as sizing. And all of those exist within property sets inside of OneFuse. So all of the values that exist within there would get associated as well. So if somebody chose WordPress, this is going to get associated. Right? What OS? Now, you'll notice here, I've got a property, a OneFuse SPS OS property, and I got a value. I can nest these groups within one another. So if I say this is WordPress, and I know WordPress uses CentOS 7, I also want to associate everything related to CentOS 7, I can now pull in another group from this group to represent that. So now we start to get to this situation where we can start to get a little bit more efficient with how we're doing this. I don't have to put OS stuff inside of my app, because I can just reference it and keep it contained within my OS. And you'll see the same things kind of carrying over here. I've got some stuff here defined around the OS family and name. And then I've got these VRA7 and VRA8 props, right? So if I'm making this request from VRA8, I can specify, well, if it's using this, we want to use this CentOS 7 for WordPress, what image, or if I'm doing a cloud blueprint, or what image reference if I'm doing a vSphere blueprint, should I use? I can override those things within VRA. So now my blueprint, I don't have to pin it to a CentOS or Windows, right? I can derive it from these values that I define in these groups, and depending on how I consume them, as well as the customization spec. That same thing holds true for VRA7. The only difference is we're using different constructs here for 7. But I can now create this abstracted layer that if I'm still using 7 and I'm using 8, and I want to consume things consistently, I can define what this represents to each, and now build my more consistent blueprints that when it looks up these values, or this particular property group gets associated with it, it's going to use the appropriate name value pairs that it should represent. And we can do very similar things and provide value when we start to look at things like sizing as well. So I've got property groups here for size, and here we see again that VRA7, VRA8. Right? In VRA7, I might be setting CPU count and memory size. So if this is what I defined as a medium in my environment, and a request comes in from 7, I'm going to set that appropriately. But in VRA8, I might be using a flavor already called medium that has the right value set. Right? And so, however, just by assigning or giving the option to my consumer to choose this one size, it's going to work across VRA7, 8, other platforms as well, and give you a sort of standardized way to set up your sizing across multiple different platforms and tools. So when we go back into VRA, we start to see it here. I got location, app size. So again, all referring to those different those static property sets within OneFuse. And so as we saw down here earlier, there were some things like what's my AD policy? Which one do I really want to use? Or what's my IPAM location and IPAM environment? These values are getting derived based on the values that are coming from those groups. So once those groups are selected, down here we can see based on the input that came in, they're going to get associated with this particular property as the value. That's going to do a lookup in OneFuse. It's going to pull in all those other name value pairs from those groups, and then those in turn are going to go ahead and displace these placeholders with the appropriate values. And so in this case, I'm actually pulling AD policy based on the environment. So if you choose production, within that group, I've defined this AD policy property, and it's got a value, and that's going to be used to displace this. And then the same thing comes down here. What DNS policy do we want to consume? And then what is that DNS suffix that we want to use? And in this case, I'm actually deriving it from the IPAM policy that was associated, but it can be taken in as an input or derived in any way that we want. Now, the interesting thing about NICs is we do support all 10 NICs that vSphere would support. We also support adding virtual interfaces to those NICs. Now, we don't actually add the interface to the VM or the workload that's being deployed. What we do is we reach out to the IPAM provider, we get the relevant information, we write the values back as properties to VRA. So if you have a script that's going to add a virtual interface to, say, you have NIC 01, NIC 02, you can then look up that information and associate it with the appropriate virtual interface. So there's a lot of flexibility. We can also do the same for DNS. You can create those additionals there, and have additional DNS records created for those additionals as well. Now, if we move it down a little bit further, there's a property that's a little bit different than all the rest we haven't talked about, which is this OneFuse create properties _ compliance. And in our case, in this example, we're asking the consumer, is there any kind of compliance that needs to be associated with this? And one of the choices is none. So we don't necessarily want to associate a property group if the choice is none, because we don't really need to do anything. So we have this ability to dynamically add properties based on these selections. And so here we have this create properties compliance, and you can see we're using some of the blueprint expressions here to look at the inputs, determine if it was none or not. And if it was none, we're not actually going to add the property, but if there was a value selected, we're going to add this OneFuse SPS compliance property and set the value appropriately so that all of the properties within that group also get added. And so that can be done very dynamically. They don't have to be statically set here like the ones above, giving you that flexibility to now take this blueprint and be able to use it for a lot of different use cases, not just building it out for a specific one. And granted, there's a lot of value and a lot of reasons why you may want to build blueprints that are static, especially those more complex applications where you might have a lot of different machines and networks and a lot of different things going on this canvas. But you may also, for those infrastructure as a service workloads or things that can be done in a much more dynamic way, present blueprints like this, where your consumer, and based on what the choices are that they're going to select, can drive the outcome of what's going to be done without having to know all the intricate details of what network do I need and those types of things. And on that topic, if we look at our IPAM policy property here, and we're determining the policy based on a number of factors. So we see this a lot when we work with customers. There might be, in this case, it's a simple example, 2 factors, but you might have 4 or 5 different things where you say, well, I've got a network that can be used for production. It can be used for, it's in our Atlanta data center. It's only for database servers, and they have to, conform to this level of compliance or whatever it might be. And if we know those 4 answers, right, we're taking in these different inputs from our consumers, and those inputs, again, are translating to those groups in OneFuse. we can have things defined in those groups that help us determine what network should go on based on those types of factors. And it may not be as simple as just take these 4 things and concatenate them together, and now we know based on how we named our policies, but you can also use logic in there. We can use if logic, case logic, and those types of things. Again, if you're not familiar with the Jinja 2 language, you can certainly look it up. It's got a lot of capabilities that you can use, and you can use it within those property groups to make decisions as well. Furthermore, I don't have to define any of these things at all. Here I've got AD policy statically put here, and I'm looking for what's that AD policy. But what if it's a Linux machine? Well, like we saw in one of the other examples, I had a tagging property defined within one of my groups that's going to go ahead and add the appropriate name value pair to go ahead and add tags dynamically through OneFuse. I can do the same thing with any of these policies. So if I know the OS is Windows, I can just define this name value pair in that group that I have for Windows, and it only gets added if it's a Windows machine. If it's Linux, it doesn't get added. So giving you even more flexibility. And so really it comes down to your specific use cases, how you want to build out a blueprint to be as flexible and work within the business logic that works for your organization. Now, outside of building blueprints inside of VRA, OneFuse adds some additional capabilities as well that wasn't previously available with our legacy or our heritage modules for VRA 7. All of our workflows that are available and that get used for talking to and integrating with OneFuse from VRA are also available for you to use outside of the life cycle of EBS. So if you wanted to create naming as a service, you can consume these workflows. You can even wrap your own workflow around it if you wanted to, and do something like this, where your users come, they select they fill out the information that they need to provide, submit a request, and it returns them a name. In here I have IP address, DNS, but then it gets even more interesting when you start talking about how do you provide these types of services for things outside of the virtual world or things outside of automation. People still need to put together names for things like routers and switches or physical machines. They need IP addresses, DNS records, all those types of things done for these other types of objects. And so maybe it's a switch that the network team needs to mount. They're going to put it in the Atlanta data center, and it's for a production environment or whatever the relevant information is. And they need a name for it, they need an IP address for it, and they need to have it put in DNS. In this case, you can have a request form like this. They go ahead and say submit, and all of those things are going to happen. The name and IP information gets returned, and they don't have to worry about going and creating that DNS record, going and getting it manually from IPAM and trying to figure out what the name is, if it's in use or not, all those different things. If it's a machine, we may want to give the option to put it in Active Directory. We might have completely different information we want to collect on it. And with the OneFuse, the way the plugin was built for VRA, you're able to do that. Or you may want to consume it within your own workflows. We've seen historically in VRA 7, a lot of organizations built those XaaS workflows that had a lot of logic up front and then would ultimately call Blueprint in the back end. What application do you need to build? Maybe if you have blueprints for those more complex applications and you have many different blueprints for many different apps, you don't want a catalog full of those blueprints, but there are things you can ask your consumers using those XaaS blueprints to come to a decision and make that determination as far as which of those blueprints is the appropriate one. But you may want to do other things up front, right? You may want to ask them some inputs. What environment is this? What is this for? Those inputs can still translate over and look up property groups within OneFuse to get more relevant information based on the data collected. They can call any of the integrations. So if you want to call them out of band beforehand because you need to use that data before the machines actually get built, you have the flexibility to do that and call those workflows. So here you'll notice under OneFuse, the configuration There is some specific vRealize 7 and 8. However, you just run the configuration workflow. We detect which one it is. And then for each of the different modules, there is a vRealize 7 and vRealize 8 folder, but there's also this manual folder. And we provide both provisioning and deprovisioning workflows that you can consume in any of your own workflows, or directly just expose them up as XAS items and use them as is. But if you want to extract the information, not make it so that your consumers have to pass you specific information on that service, you could wrap it and extract it as well. And so, one last thing that we'll take a look at in OneFuse that we didn't really go through is, as I pointed out, all of the modules do keep track of the objects related to the module within it. But then there is that historical job area where you can always go back and look at and get that audit trail, if you will, on everything that's taken place from an integration perspective within the environment, right down to how did the request come in? Was it API based? Was it vRealize 8, vRealize 7? We do have a Terraform provider as well for consuming all these integrations that supports all of these things. And of course, the API has a Swagger interface for documentation as well, which you can easily access right here within OneFuse, and allowing you to consume OneFuse from pretty much any tool that you want. And one of the areas where we're really helping some of our existing customers as they migrate to OneFuse is becoming consistent and standardized across these tools. So standardizing vRealize 7 and vRealize 8, there's some use cases that are currently, some of our customers are still consuming from vRealize 7, even though they're now adopting vRealize 8. They just can't get everything there yet. So now they're doing requests through both of these systems, but they can remain consistent, right? The same groups, providing the same business logic or same values based on your business logic, the same integration, same policies across both of those. They have pockets of people consuming Terraform, and being able to provide these policies for consumption in Terraform as well, so that these things are being named based on their naming standards and being placed on the appropriate networks, getting the right IP information, and so forth and so on. And on that note, I'm going to go ahead and pause there and open it up for any questions.
Yeah, so one question. Sorry.
Go ahead.
I wasn't sure if you wanted me to read the questions out loud to you or not.
I think I see a question that says, can OneFuse remove the barriers to full automation? And I'm not exactly sure what is meant by full automation, but as we saw some of the things that we walked through, it does break a lot of the barriers down, right? Because when we start to look at automation, one of the big things is how do we standardize and how do we do it easily, right? Without having to write custom code. When we start seeing organizations that are trying to really heavily adopt automation, there's usually a lot of custom code involved. And although, in the 1.1 version, you'll only see DNS, IPAM, AD, and naming, we do have agentless scripting as well as Ansible Tower support coming in our next release. We have support for ServiceNow coming, and a lot of other endpoints will continue to come. So very, very easy way to consume these integrations, but do it in a very flexible and dynamic way. So that we're trying, our goal with how we build these modules is to make them as least rigid as possible, so that you don't have to write code to get around things that were built a certain way or done a certain way that don't work for you. Does this work with other platforms other than VRA? Yeah, so I mean, we have the plugin for vRealize 7, vRealize 8. We do have the Terraform provider, and then there is the API that can be consumed via any platform that you like. We do have a fully documented API. There are Postman sets out there for easy examples. I've got a customer that I'm working with right now. They do scripted physical server builds. And as part of their scripts that they use for their server builds, they're actually tying in API calls back to OneFuse. So now instead of having to supply the name, the IP address, go do all the DNS stuff, they're now adding automation to doing their physical builds as well. Any other questions out there? I saw one that said how with a question mark. I'm not sure what that was in the context to. How is the prize draw determined? Email or phone call? That's a great question. I personally don't have the answer to that.
It'll be an email.
It'll be an email. There you go. Fantastic. Any more questions, comments, anything at all?
And we got a comment. Great presentation.
Thank you. If anybody would like to go deeper and see more around how this actually works, or if you have a use case that you would like to see implemented in VRA8 with OneFuse, definitely reach out. You can reach out in a number of different ways. If you want, you can feel free to go to our website and fill out the contact form, and then and have somebody reach out, or yeah, that would probably be the best way to reach out to get you with the appropriate team. Again, if you want to reach out to me, you got questions specifically for me, I can be reached at smith@cloudbolt.io. Feel free to send me an email. I can answer your questions or even direct you to the appropriate people as well.
All right. Well, great. Thank you so much, Sid, for taking the time to speak with us today.
My pleasure.
Of course. As a reminder to our audience, you will receive a follow-up email with the on-demand link from today's webcast. To find out more about the VMUG Webcast program, visit vmug.com and check out the education page. Please make sure to complete the short online evaluation that will pop up as you exit the webcast, and let us know how today's session went. And from all of us here at VMUG, thank you and have a great rest of your day.